Okay, we've been given a question where we're asked to rotate a function, namely the square root of r squared minus x squared, around the x-axis and use this to determine a formula for the volume of a sphere radius r. Okay, so I think it's worth noting that the volume of rotation of a function can be determined using this formula, the pi times the definite integral from a to b of the function that we've been given squared dx. Okay, so what we're going to do is we're literally going to put this function into this algorithm. So the first thing that we're going to have to do is we're going to have to figure out what our upper and lower bounds are for our integration or our definite integral. So if we have a look at this function here, hopefully you'll be familiar with the function that gives you a sort of a circle that looks like this, and you'll know that the radius of this circle is just this r value here. So the values of x that we're going to be integrating to and from is going to be, well, this one here is going to be negative r, and this one here is just going to be r. So what we're going to do is just change color. Is we're going to input this into this function. We have these upper and lower bounds for our integral, and it becomes quite simple from there. So we're going to say the volume is going to be equal to pi times the integral from negative r to r of the function, which is the square root of r squared minus x squared. And then we're just going to square that dx. Okay, the first thing it's probably simple to see that squared is now going to cancel out the square root part of the function. So this is now just going to be equal to pi times the definite integral from negative r to r of r squared minus x squared dx. Now, the next thing we have to do is we're going to have to actually take the integral of this, or anti-differentiate it. So, by doing that, what we're going to do is we're still going to have the pi is just going to sit out the front. The anti-differential of r squared in regards to x is just going to be r squared x, and we're going to be taking away the anti-differential of negative x squared is going to be negative x cubed over 3. And we have to evaluate that between negative r and r. Okay, so once we've done that, we literally just sub in our upper and lower bounds. So this is going to be equal to pi multiplied by what it's going to be at the upper bound. So r squared, we sub in r for x, so it's r squared times r, which is r cubed, minus r to the power of 3 over 3. Subtract the lower bound, which is going to be r squared times negative r, which is just going to be negative r cubed. Subtract, put the negative r in here because it's an odd power, it'll stay negative. Subtract negative r cubed over 3. Now, if we do a bit of algebra on this, simplify it down a little bit, we've still got the pi sitting out the front, it's not going anywhere. We've got r cubed minus r cubed over 3. So 1r cubed is the same as saying 3r cubed over 3 minus r cubed over 3 is going to be 2r cubed over 3. Subtract. Now we've got negative r cubed minus negative r cubed over 3. So that's like saying plus r cubed over 3. So negative r cubed, which is negative 3r cubed over 3, plus r cubed over 3 is going to be negative 2r cubed over 3. And you can probably see where this is going now. This is going to be equal to pi. Now, 2r cubed over 3 minus negative qr2 cubed over 3. It's a bit of a mouthful. These here turn into a plus. And we're left with 2r cubed over 3 plus 2r cubed over 3 is 4r cubed on 3. And finally, we can then say that therefore the volume of a sphere is equal to 4 pi r cubed over 3 units cubed. And that is the solution.